What's up, AP Stat students? This is Miss Taylor coming to you with almost your last probability lesson. So we're going to get into it. It's called probability using tree diagrams. So let's go ahead and get started. So you use a tree diagram. It's just a way to organize your thoughts instead of like using a table when you have counts. Well, you have percentages, and these percentages are based off of conditions. And so you can't really use the formulas until you can figure out what type of math is going on. We got to see it. So I'm going to go ahead and read the prompt. Management has determined that customers return 12% of items assembled by inexperienced employees. So they're saying if an inexperienced employee assembled it, 12% of the time is returned. So that is a condition. You know it's been assembled by an inexperienced employee. 12% of them get returned. So then that only happens, 3% happens with experienced employees. So those are conditional statements. So this is a conditional number and those two are. But in that last sentence, which is where we need to start, it says inexperienced employees assemble 20% of the items at the plant. So therefore we know that the other percentage is the experienced employees. And that's where you have to start. You have to start with the one thing that doesn't have a condition on it. That one, like, oh, I know it's going to be 20% and 80%. So here we go. This is how you kind of organize it. So we're going to start with a bracket. And that bracket is going to consist of experienced employees versus items assembled by inexperienced employees. And so we're going to draw the percentages that we do know. We know that 20% of the items are made by inexperienced employees. Therefore, 80%. Every time you do a tree by itself, this part, those two branches need to add up to 100%. And so that will give you your organization. So as we keep going, what happens? So we have two things that can happen with both groups. The item is returned or the item is not returned. So that is how we're going to separate everything. And so for experienced employees, 3% of their items are returned. So therefore, remember, you need to add to 100%. So you know 97% of their items aren't returned. So then let's go to inexperienced employees and set up that part of the diagram. So in that part of the diagram, I still have what's returned. Well, they said 12% of their items are returned. And therefore you do math, 100% minus 12% is 88. And that's where I get those numbers. And notice that 3%, 97%, that's 100% of what the experienced employees' items are being returned or not returned. The same thing for inexperienced items. So now once we have that, well, let's just look at what that means. So if you notice, those are all the four scenarios that could happen. First scenario, you can have items that were made by inexperienced employees and returned. So when you use the branch, it's multiplication happening because and is happening as you go through. So if you start here and walk your way all the way through, you have to multiply as you go. So notice I did 0.8 times 0.03. So that branch represents experienced items that are returned. So if I want to go to the next one, it's still multiplication that needs to happen. So that one represents experience and not returned. And then you can just go on through. You always multiply them as you go down. And so those are all the four scenarios that happen. And if you look at the math, adding them all up, since that's all the possible four scenarios, that's going to be 100% or 1 as a probability. That's what that is. And what's so great about it too, if you look at the math here, those represent the 80% of items that are done by my experienced employees. So obviously if I added this up, that's going to be that 20% right here. And so you don't have to do this every time, but I want you to understand where the branch comes from and where the math is and why we're multiplying. Now let's actually do part A and part B of this. All right, it says, what is the probability that an item is returned? There is no condition on that. We don't care if it was made by an experienced employee or an inexperienced employee. It doesn't matter. It just says what's the probability that an item is returned. So we need two branches. We need the branch of returns that were made by experienced employees, and we need returns made by inexperienced employees. And so again, how you start, you must do multiplication. So the probability of return is the experience and return people, that's this number. And then the second group is the multiplication of 0.20 times 0.12. And you would add them together, and that would be the probability of any item being returned, no matter who made it. Okay? So that is the probability that the item is returned, and that's how you do it. So now let's do the second part of this example. So we're going to continue with the same math in the same tree. It says, if an item is returned, there we go. We have that conditional if an item is returned. What is the probability that an inexperienced employee assembled it? All right, so what does that look like as a probability? What are they trying to make me find? They want me to find, and we already wrote it, they want me to find this. The probability of inexperience if you know the item has been returned. So the probability that an inexperienced employee made the item and it was returned. So this is the formula we have to use. So basically it says that you need this branch. You need the branch to get this math right here. I should use a different color. So to get that branch right here, let's do highlight. You need inexperience in return. You need these numbers right here. So that's going to be your numerator. And then the probability of return, you just figure that out. So I'm going to put that in purple. You need the addition of all returns. You need that. So we've already done that, so we actually know our denominator. So probability of inexperienced return, again, that's that YOL at 0.20 times 0.12 divided by the probability of just return, which is what we did in the previous one. And we divide it, and that is our answer. Okay, so I'm going to stop the PowerPoint here so I can do the other two examples in another video. So if you want to try those out just to see if you can create your own tree diagram with example 2 and example 3, at least start there. See if you can read the problem and come up with your branches, and then we can do the problems together. So I will catch you guys in the next video.